last part of chapter 11, we will be talking about PCA, Principal Component Analysis. In many real-world problems, we may find a dataset with a large number of variables. Sometimes we have very large number of variables. This dataset that contains many variables or dimensions are referred to a high-dimensional data. In some scenarios, by the way, you will be facing the idea that you have number of variables way exceeding number of observations. And this is a problem. So that's why we call them high-dimensional data. Sometimes you will be able to eliminate some of these redundant variables. But in other cases, if you try to drop any of these variables, you may lose valuable information. So that's why we are going to use something called PCA. It is a dimension reduction technique. It's effective when you want to reduce number of variables, but you cannot completely eliminate any of these variables from the predictive modeling without losing important information. The PCA basically transforms a large number of possibly correlated variables into a smaller number of uncorrelated variables, and these variables we're going to call them principal components. By the way, we're going to have a problem of interpreting these newly established variables because we will have another set of variables. We call them principal components, PCs, all of them PCs. We will not have the variables that we initially started with. We are going to have new different set of variables. And these PCs allows us to summarize the data with a smaller number of representative variables that collectively explain the most of the variability in the data. The last thing we're going to do here is just to say about the PCA. PCA is unsupervised data mining technique. And again, it allows us to select a relatively small number of PCs that drive most of the patterns found in the data. It can, for example, be used to visualize and to pre-process data before applying other unsupervised learning methods such as clustering. Also, we still can use PCA with supervised learning methods like the linear regression or logistic regression, where a large number of predictor variables can be substituted with a smaller number of principal components. But again, what we pay back here is the interpretation power that we had when we have the original variables in the linear regression case. So this is everything about the PCAs. I'm not going to go into the details of the structure and how we do the calculations here, but we're going to use an example. We're going to do an example in R and see how we interpret the results.